All right, in the last video, we left off after doing all 9 different Pythagorean identities, where they came from, what they were, and doing what our reciprocal identities are and what our quotient identities are. In this video, we're going to go ahead and we're going to start by simplifying our identities or simplifying equations that we have and seeing what we can do here. All right, so for example, in this case, I'm given cosine cubed plus cosine x sine squared x. And I've got to simplify this. So I just got to kind of think about it in terms of what do I have? What can I do? If I gave you x cubed plus x y squared and asked you to simplify that, you'd be like, well, I can see that they share an x. So let me maybe pull that out. So that's exactly what you would do here. I would instead see, okay, there's a cosine cubed and there's a cosine here. So since there's one in both, let me go ahead and factor that out as a GCF. So I'm going to write that on the outside, and then I'm going to go ahead and I'm going to write what I'm pulling out underneath each term. I'm going to simplify it and make sure that I don't leave anything behind and that I do it correctly. And if I have 3 up top and 1 in the bottom, that cancels out one of them and leaves me with cosine squared, right? And then over here, I'm going to cancel out that cosine x on top and bottom. And that's just going to leave me with plus sine squared x on the inside, okay? Now, because I know my Pythagorean identities, I should see right here on the inside that cosine squared plus sine squared sitting right there. And I should know from my Pythagorean identities, well, that's our very first one that we had here. That's the most important one that we learned. That's what all of these are based off of. As soon as I see something like that, where I see cosine squared plus sine squared, I'm going to immediately take that and I'm going to turn that into 1. So really what I just have here now is I just have cosine x times 1. Well, we don't really write something as times 1, do we? We just kind of get rid of that. That's no longer relevant. And so this whole thing simplifies down to just cosine, okay? Let's try another one. So if I look at number 2 here, I should go, oh, wait a second. This is very similar to the last one where I've got a cosine squared and a cosine squared. So let me go ahead and pull that out. So I'm going to write this with a cosine squared on the outside because that's going to be my GCF. And I'm going to divide both terms by cosine squared and write what's left on the inside. So if I do cosine squared divided by cosine squared, that cancels out. It doesn't go away. It becomes 1. And then over here, I'm going to have cosine squared divided by cosine squared. That cancels out, and that just leaves me with that tangent squared. Well, shoot, tangent squared. I've got a 1, I've got a tangent squared. I'm going to go ahead and think, let me look at my Pythagorean identities. And sure enough, 1 plus tangent squared is right there. So it equals secant squared. So that's what I'm going to change this into right here. As I'm going to go, well, this is secant squared x. And I'm going to go ahead and bring that cosine squared down. So now I have cosine squared times secant squared. Well, you might be able to recognize what to do right here, but just in case you don't, when I have something like this, I'm going to go ahead and change it around a little bit and see if there's anything I can do. Obviously, I don't want to turn secant squared back into a Pythagorean identity because that didn't help, because that's what I had right here. So I don't want to do that. I don't want to turn cosine squared into 1 minus sine squared because that's not going to help me. Instead, what I'm going to do now is I'm going to lean on those quotient and reciprocal identities, and I'm going to start turning everything that I have into sines and cosines and see if that helps. So if I come down here, cosine squared's already in terms of sines and cosines. So instead, what I'm going to do here is I'm going to turn that secant squared into 1 over cosine squared, because that's my reciprocal identity of secant squared. And so now what I have is I have cosine squared times 1 divided by cosine squared. Well, hopefully we see it, but just in case we don't, remember that if you're multiplying fractions, they just go straight across. And so that's going to get me cosine squared over cosine squared, which, okay, we should see it there. That's going to cancel out completely, and it doesn't equal 0, it equals 1. So this identity, or this expression that I have written here, cosine squared plus cosine squared tangent squared, simplifies down to just simply 1. Okay, let's try number 3 here. So this one looks a little bit more complicated. So let's go ahead and look and see. If I go ahead and notice all of these are squared, the reason I'm not turning any of these into my Pythagorean identities is because if I did, say for example, let's just pretend and let's just change cosine squared, that would be 1 minus sine squared. And if I did that, that means that 1 minus sine squared is times sine squared times tangent squared. That's just overcomplicating things. I'm taking something that's just one term, there's no addition or subtraction in this, and I would be changing it and making it into multiple terms. We don't want to do that. So instead, again, I'm just looking for what do they share. So I can go ahead and I can take both of these and recognize that they both have a tangent squared and a cosine squared. So let me go ahead and divide both terms by that tangent squared and that cosine squared and simplify it down and see what I've got. Now, keep in mind, there's more than one way to solve pretty much all of these. Sometimes just one way might be easier than the other. So I'm going to go ahead, I'm going to write this tangent squared, cosine squared on the outside because I'm pulling out a GCF. And if I do that over here on the right, tangent squared, cosine squared divided by tangent squared, cosine squared, well, that completely cancels out, and I'm just left with 1. And then if I do it over here, tangent squared, cosine squared cancels out, and I'm just left with minus sine squared. Okay, so we're getting somewhere. I should recognize that I have a 1 and I have a squared term. Anytime I have a 1 and a squared term, I want to go ahead and see, is this a Pythagorean identity? Is there something that I can do with this to make it not be 2 terms and turn it into 1? And sure enough, if I come up here, I'm going to see that I've got 1 minus sine squared is right here, and that equals cosine squared. So that's what I'm going to come down here and do is I'm going to turn that into cosine squared. So now I have tangent squared times cosine squared times cosine squared. I could go ahead and I could combine the cosine squared and turn that into cosine to the 4th, but I'm not going to yet, simply because I'd rather see multiple of them than have a big exponent. Why couldn't I think of the word exponent? I'd rather have them separated out just because it kind of makes things a little bit easier for the sake of canceling sometimes. And instead, what I'm going to do is I'm going to turn this tangent squared into my quotient identity, which says that sine squared divided by cosine squared is equal to tangent squared. And so now, if I go ahead and bring these values down, I can see more clearly what I have when I cancel out. And so that's exactly what I'm going to do here, because remember, when you're multiplying fractions, you just multiply straight across. So this numerator would become sine squared, cosine squared, and the denominator would become cosine squared times 1 times 1. Well, one of those is going to cancel out. And that's just going to leave me with sine squared times cosine squared. Now, this is as simple as this one gets. That sine squared plus times cosine squared does not cancel out and equal 1 because there's no plus sign. If there was a plus sign there, sure enough, it would equal 1, but this is multiplied, so it is not equal to 1. Another thing to make note of with all of these Pythagorean identities, they all have that exponent of 2 in there. So like, for example, if I have cosine plus sine, that does not equal 1. That does not equal 1. So make sure that you remember that it has to have an exponent there, okay? So always make sure it's got that exponent, okay? All right, let's look at number 4 that we've got right here. So this one looks a little bit more complicated. I don't have anything squared. So from here, I can go ahead and I can start kind of changing things around. But since I don't have anything squared, what I'm going to do is I'm going to go ahead and start putting everything into terms of sines and cosines. So I'm going to change everything over to its reciprocal if it's not already sine or cosine. All right, so for this one, we'll go ahead and rewrite this. So I have tangent x is sine over cosine. And then sine x, well, we already have that in terms of sine and cosine. So I'm going to write that sine over 1. And then secant x would be 1 over cosine. Okay, that's going to be my numerator. And then I'm going to go ahead and write my denominator. Now, if you notice here, I've already got it written as a fraction. So instead of writing a big old fraction over a fraction, instead what I'm going to do is I'm going to go ahead and write it so that I've got the division sign like this. And then I'm going to do my whole denominator over here on the side like this. So instead of cosecant x, I would have 1 over sine x times tangent, which is sine over cosine. Okay, so now I've got it written in terms of everything being sine or cosine. If I go ahead and look right here at this numerator, I have a fraction plus 2 things multiplied together. So, and I've got to multiply this here and here. And so that's going to get me just one thing on the right there. So I'm going to go ahead and rewrite this as just having sine over cosine plus sine times 1 divided by 1 times cosine just gets me sine over cosine. Well, that kind of helps things out a little bit here. And then if I go ahead and look at just this denominator over here, I have 1 over cosine times sine over cosine. I should see that these signs are going to cancel out, and that's just going to leave me with 1 over cosine as my denominator. Okay. Now let's go ahead and look at what we can do here with this left side. So I have sine over cosine plus sine over cosine. Remember, anytime that you have a fraction and you're getting a common, in order to add or subtract, you have to have a common denominator. Here, I do have a common denominator, so I'm going to go ahead and add those together. Now, if I have 1/4 plus 1/4, I'm going to go ahead and what I do in this case is I do 1 plus 1 and I get 2. The denominator doesn't become 8. I just leave that as 4. Your denominator stays the same when you're adding or subtracting fractions. You just bring the denominator over with you. Now, the numerator does change. Those combine together. And so I have sine plus sine. Now, think about it this way. If this was x's, if I had x plus x, that would not become x squared, would it? No, instead it would become 2x. So that's exactly what I'm going to have here. I'm going to have 2 sine x. So I'm going to go 2 sine x, and then that is divided by cosine x. And then I've got that divided by 1 over cosine. And so I'm going to go ahead and do that part. Now, keep in mind, if you have a fraction and you're dividing by a fraction, or really if you have a fraction and you're dividing by anything, you just do keep change flip. So this is going to be 2 cosine x over cosine x times, and that cosine x is going to flip and come up top, and that 1 is going to come on the bottom. And I should see right here that those cosines are going to cancel right on out. And this is going to get me 2 sine x. So there we go. So that's what that simplifies down to. I've got 3 more to do, and I'm going to go ahead and do those in a second video covering this information just because one of them is going to be a bit longer. So watch for that next video.